Hi, Assalamualaikum. My name is Intanur Aisyah, and today I will show you the water reticular system that we designed by my group member, Rabiatul Adawiyah, Hanin Shatira, Fatin Amira, and Megat Khairul Hakimi. First of all, our pipe layout consists of 3 loops, which is loop 1, loop 2, and loop 3. Firstly, we need to identify the node of our pipe layout, which is node A, node B, node C, node D, H, and so on. Okay, here is the flow of the water through the reservoir. And also from the pipe layout, we need to identify the reduced level, platform level, and top water level by using this formula. As you can see, the pipe material that we use is high density polyethylene. The reason that we use the high density polyethylene is because it has a high strength to density ratio. High density polyethylene also has a little branching that giving it stronger intermolecular force and tensile strength. And lastly, HDPE, which is high density polyethylene, is chemical resistant, so we can use it for a long period. And the diameter of the pipe is 20x cm. The Hazen-Williams roughness coefficient, which is C, is 113. And then we need to identify the dimension length from A to B, from B to C, and so on. And after that, we need to calculate the water demand, where the water we supply. So the water demand we supply to hostel, admin building office, and also for the cafeteria. How to calculate the water demand? We calculate the water demand based on the Malaysia Water Association MWA guideline. And from that, we can see here the education institution with fully residential demand is 360 litre per day for each student. It is referred to table 1. And from that, we know the floor is 5 and occupancy per floor is 200. And from that, we can get the number of equivalent population. And after we get the number of equivalent population, we can calculate the water demand. The way to calculate the water demand for admin building office and cafeteria is also same like the hostel. And then we need to sum all of the water demand to get the total water demand. And after that, we need to define between peak flow and fire flow which one we will use. And as you can see here, because of the peak flow is higher than fire flow, we use the peak flow as our design flow. And after that, we total the water from reservoir. Next, in order to find the flow rate and head loss in the pipe, we use head balance method. As you can see, we need to assume how much the flow rate that will be distributed on each pipe and consider it is clockwise here. And we can find the head loss by using the Hazen-Williams equation. And also we can find the correction flow pipe by using Hardy-Cross method. Okay, now you can see the first iteration which has 3 loops, loops 1, loops 2, and loop 3. And then we need to put the flow rate that we assume at here and the head loss that being calculated. And as you can see here, the summation of head loss is not 0. So we need to do it until we get the 0. So because of that, we need to do the second iteration and until 6 iterations. And yeah, as you can see, we get the summation of H is 0. And then we need to calculate the residual head by using this equation. And we use the summation of head loss that we get from the 6 iterations. And then we need to check either the residual head is higher than 7.6 meter or not. If it's higher, it's okay and our design is accepted. And here is our tank reservoir design, the type of reservoir design, the vector we use the type.
And this is the layout.